Hi, my name is Brian Pentland, and I want to talk to you about visualizing clinical trajectories with ThreadNet. The panel is covering three questions, and since I think this is being played last, you've already heard them. So let's dig in. What's the theoretical issue that I'm interested in? Well, this model of routine dynamics is the thing that we're really trying to understand. This is derived from a paper we wrote a few years ago. If you look on the right-hand side, you'll see a set of sequences of numbers which represent performances of a routine or threads or stories coded as integers. And on the left-hand side, you'll see a pattern or a network. That's actually an adjacency matrix, and colors represent the frequency of transitions. So that pattern gives rise to performances, and the performances can regenerate the pattern. It's the sort of basic model of routine dynamics that we're trying to understand here. You can look at the trajectory of this network structure over time. So for example, it might start off very simple, a simple straight line, and as you start to get variations, you might see extra edges being added into the network. And it could get quite dense, quite complicated in the middle. We have a simulation that we've done that allows us to look at the trajectory of complexity over time using this network-based measure of task complexity that we published a couple years ago. So these are the elements that we're putting together to understand the dynamics of routines and the complexity of routines over time. Now, how do we analyze trajectories? Well, the main difference here is I want to explain what I mean by a trajectory. I think of it in terms of a change of an action pattern over time. So a single narrative or single thread or a single performance is a path, but the network overall is a pattern. And so a trajectory is a changing network. Now, to analyze this, we've written a software application called ThreadNet. It's a package in R. It's open source. You can download it from GitHub, or at that URL at the bottom of the screen includes instructions for downloading and running and using. The basic idea is you read in your data, choose a point of view by defining what you want to see in terms of the threads and the events, and then it allows you to visualize and compare in a variety of ways. So the idea is that ThreadNet weaves threads into networks. Right? That's the sort of concept of it. And in terms of sort of more theoretical terms, it weaves stories into narrative networks. So this narrative network idea is unlike a social network because the nodes are categories of action. Right? They're not people or organizations. And the edges are the sequential relations between those actions. Right? And what's cool about it is that a narrative network is a convenient way to summarize a pattern of action and also the possibilities for performing the patterns. Right? So ThreadNet includes other kinds of visualizations as well, but this network idea is the thing we want to focus on now. So let me give you an example. We're analyzing clinical routines. That's just what this research work's about. My co-investigators on this are Julie Ryan and Alice Pentland at the University of Rochester Medical Center and Ken Frank at Michigan State University. At the URMC, we're looking at dermatology clinics, actually. So the data comes from electronic medical records from the audit trail and also interviews. We're starting off with dermatology because that's a very straightforward, kind of simple routine. And then we'll move on to more complex settings like orthopedics and oncology. And the question across these settings is what drives the complexity in the clinical process? And the interesting thing, of course, is that it's not just one thing, right? It changes over time. So we need this trajectory idea. So we do this starting from electronic medical records. So at dermatology clinics, we've got 2 years of data. It's about 35,000 patient visits. Which means 1.2 million time-stamped records like the ones you see here. And so that gray area there is like when the patient checks in. And I'm not sure you'll be able to see this, but the timestamps, every few seconds, something's happening. So first you check in, and then they take you to the room where the licensed nurse will get vital signs and enter your chief complaint and so on. So in a typical day, a dermatology clinic would have 25 or 30 of these visits. The lines that you see appearing here are each trace there, each thread is a visit to the clinic, right? And what we do is we take those threads and we weave them into networks that represent the pattern of action for the clinic for one day. With me so far? Good. So, how to visualize trajectories? Well, basically each day, each day becomes one point, right? And you can just lay them out over time. So a 2-year trajectory looks like this. It's 498 working days. The x-axis just shows the days consecutively, without weekends or vacations. And the y-axis is a measure of how similar each day is to like the other days. Actually to a reference day, I should say, all compared against the same baseline. So when the networks are similar to each other, then that number is low, like so in the sort of big low sections. But when the number is high, the networks are more different from each other. So the process changes over time. And what's interesting is the complexity of these clinical processes also changes over time, right? So you can see at the bottom here, you've got the trace of just or the trajectory of the process, and above that is the measure of complexity based on that same network model. And it's significant stuff. You can group them over time, and sure enough. So that's what we're working with. This is just sort of an illustrative example. The thing that's interesting, the 3 questions posed to the panel, theorizing, analyzing, visualizing, to me, all go together. And the idea that I'm really most excited about is applying them to the dynamics of event networks. So I said earlier, routine dynamics. I'm trying to think of how these patterns of action change over time. As you may know, in the realm of social networks, there's a lot of interest in representing how, as ties form or dissolve between actors due to homophily or transitive closure, we get changes in network structure. Well, the thing is, social networks, they've made a lot of progress, but event networks are completely unexplored territory. We're really just beginning to think about how to represent the patterns of action and their changes over time. Now, we know that processual phenomena change, right? That's undoubtedly true. But I think what we need to do is learn how to see in this realm, right? So the analyzing and visualizing are extremely important. We need to develop theory and conceptual vocabulary. So in social networks, they have ideas like homophily, but in the realm of event networks and action networks, I'm not sure we do. We also need to develop visual literacy. So when we see certain kinds of graphs or certain kinds of trajectories, we understand what we're looking at. And that's what ThreadNet is intended to help with, to help people very simply use data. No programming is required. The format is straightforward, makes minimal assumptions about the data. So it's not limited to just routines and healthcare, right? You could put any kind of a thing in there. And it's not a big data thing either. You can, if you've got 8 or 10 interviews and you can code them as sequences, you can see what the patterns look like. And it's free. It's an open source product that you can just download and run. And if you do, please let me know. I'm curious to see how it works out. Thank you so much.